Okay, so here goes number 4. Number 4, when we first start to factor, you'll see something that was actually one of the next things I wanted to talk about with factoring, is you technically should always, 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 with factoring, look and see if there's a greatest common factor that you can take out first. Okay, so in other words, when I'm looking at this numerator, I notice that, excuse me, there's an x in every single term. So the first thing I'm going to factor out here is an x, which leaves me with x squared plus x minus 6. Okay, I'm still not fully factored, so I'm going to go ahead and go down on the next row here. And let's just leave this one alone for now. But if you can take out a greatest common factor, you need to. So now, the nice thing is, this is just one of those where it's two numbers that multiply to give me -6 and add to give me 1. That would be +3 and -2. So I have x times x plus 3 times x minus 2. That's my numerator. And in the denominator, I'm looking for two numbers that multiply to give me -2 and add to give me -1. So that would be -2 plus 1. So x minus 2, x plus 1. Okay, so we do have a whole because we have something I want to cancel. Okay, remember that anything you would want to cancel is a whole. But let's be methodical about this. Let's look at the factors of the denominator. And any factors of the denominator indicate excluded values, meaning all real numbers except 2 and -1. Let's do those in numerical order. That's my domain. Okay, and those domain exceptions, those excluded values, will always be either wholes or vertical asymptotes. We just said that because it would cancel, the 2 is a whole. So we have a whole at x is 2, and the other one is a vertical asymptote then. We have a vertical asymptote at x is -1. So let's pretend that's -1. X equals -1. There's my vertical asymptote. Don't forget the whole, just wait to put it in. Next, I'm looking for horizontal asymptotes. This time, the degree is not the same. The top, the numerator, is to the third power, has a degree of 3. The denominator is degree of 2. You do have to be careful. Sometimes you'll see these problems, they will already be written in factored form. So like if it came to you like this, you would have to count x's. In other words, I could tell this is a degree 3 because I see 1, 2, 3 x's multiplied. And I could tell this is a degree 2 because I see 1, 2. Okay? So if it's not already all multiplied out like this, if it's in factored form, you have to count x's to figure out the degree. But here it's written in standard form first. So we can see that the degree of the numerator is bigger than the degree of the denominator. Now this is the ones where basically I was telling you it's almost like the denominator would divide into the numerator and disappear. Okay, so the graph isn't even necessarily going to look like a rational function. So a lot of times it would completely cancel. This time it's not going to completely cancel. But when the numerator is bigger, that means that we do not have a horizontal asymptote. And when we don't have a horizontal asymptote, that's the only time you need to look for a slant asymptote. Now if she said don't worry about it, then don't worry about it. But that's the only time you need to look for a slant asymptote, is if you know you do not have a horizontal asymptote. So no horizontal asymptote. Okay. This time I'm going to be a little more careful and find my x-intercept and my y-intercept first, so that my graph doesn't look like a hot mess. Okay, so my x-intercept means I'm plugging in y, 0 for y, which basically means I want to know when this whole thing is equal to 0, and since it's a fraction, the whole thing will be equal to 0 when the numerator is equal to 0. So really it all boils down to, when does this equal 0? Now, we're going to treat this like it's been canceled out. So x is 0 or x is -3. So I have x-intercepts at x is 0 and at x is -3. Okay. Then y-intercept. Okay. The y-intercept comes from plugging in 0 for x. So that means all my x terms are basically going to be 0. 0, 0, 0. Everything in the numerators are going to become 0. And we just said if you have a fraction with a numerator of 0, that means the answer is 0. That's what it is. A fraction only equals 0 if its numerator equals 0. So the y-intercept is 0. Well, we just so happen to already have that one there. Okay, so I think at this point I'm ready to go ahead and look at the graph and see what this looks like. Be careful about inputting it. I kind of think it's easier to put it in factored form, but when you do that again, make sure you put parentheses around everything in the numerator. So I start with parentheses, and then before I put divided by, I close with parentheses. Like there again, divided by. Then start the denominator with parentheses, x minus 2, x plus 1, close with parentheses. Go to, and I didn't do what I said I was doing. I didn't put the extra set of parentheses down in the bottom. Okay. And this is what it looks like. Okay. So it comes along up through here. And it comes along through here. So that's my graph.